Good evening, everybody. You have joined for the live webinar, The Story Behind Safe Air Journey. Before the session, we are going to mute your mics. If you have any questions or doubts, send a direct message to Q&A on the chat. So today our guest speaker is Mr. Kithsiri Samarasinghe, Senior Lecturer from University of Moratuwa, and electronic engineers from our own establishment, Mr. H.A.Priyantha and Mr. Chandana Maddumabandara will join with Mr. Kithsiri for the discussion. So I would like to invite Mr. Chandana Kolathilaka, President of Air Traffic Engineering Officers Association, for the welcome speech.
On behalf of organizing committee, it is my pleasure to welcome everyone to our live webinar program. I hope you are all enjoying yourself so far, and we promise to make this a memorable event for you all. I wish you all the best. Thank you.
Thank you, Mr. Chandana. So let's move to our main session. So I would like to give a brief introduction about our guest speaker. So he worked as electronic engineer in Electronics and Air Navigation Engineering Division, Airport and Aviation Services Private Limited from 1985 to 1997. Then he moved to Sri Lankan Rupawahini Corporation and worked as the Director Engineering till 2001. Now currently he's a Senior Lecturer in Electronics and Telecommunication Department of University of Moratuwa. Mr. Kithsiri Samarasinghe, I warmly welcome you to start the session.
Thank you and good evening, everyone who has joined. So today our session will be on mainly the role of ATSEP in air navigation. Let me start with share my presentation first. So the topic given to me is story behind the safe air journey, especially focusing on air traffic safety electronic personnel role, ATSEP role. We will be quickly discussing what kind of technical equipment that ATSEP will handle and what are their responsibilities to ensure safe air journey to the public. My presentation is also organized according to this same theme called CNS ATM. You can see the three words: C, communication, S for surveillance, and N for navigation, and all combined into air traffic management. So the word coined by ICAO is CNS ATM. So I'll first give an introduction of the navigation area, and then we will move to surveillance part as the second step. Then we will move to communications. And finally, how the ATM will integrate all features into a management terminal. Okay, discussing on navigation. Well, if you think of yourself first and ask yourself, how did I come to this room? I'm assuming you are in your room at the moment. So how did you come to your room? Well, basically we have practiced it so much and naturally we came, isn't it? But if you look at it more carefully, it is not that you just walked, but what actually happened is navigation. So you navigated yourself to your room, and also we navigate to many places during a day. So when we navigate, this is what it means: the control of the motion of vehicles to the destination through land, sea or air. Our focus is air navigation, but the navigation is more generic term which will apply to land, sea as well. This is the definition. When it comes to air navigation, we have 3 main phases actually. First, this is the kind of takeoff, and then en route navigation, and then landing phase. So altogether, it is starting with flight planning, and then pushback, then taxiing, takeoff, then domestic cruise or oceanic cruise, then descent, final approach, and the landing. So in order to support the phases, different phases of flight, in each phase we have to establish support systems, mostly electronic systems, to support each of these phases. And this is a safety critical industry, and therefore in each phase when you introduce technology, the technology has to be well proven and tested, so that the safety has to be, safety levels should be very high. So that is why we need specially trained people to absorb these technologies to the local surroundings, and then not only absorption, then installing and commissioning, maintaining, and also when faults develop, you have to do repairs, and that is preventive as well as corrective maintenance. All that is lying in the shoulders of ATSEP staff. Right? So coming back to you, if I ask you a question, how do I know where I am? Now you know that you are in your room, or you know what is in your surroundings. So actually, to locate yourself, your brain will look around for the landmarks. Your brain will be tracing the landmarks, and then your brain will calculate your relative position to each landmark, and then you are located. We call it a position fix, and you do it every moment in your day. Your brain continuously do this. So it has become so natural to us, and we don't even notice that happening now. Supposing you are here, assuming that this is the view you see, the moment you see the view, the distances to each of these units, you have automatically calculated in your brain. Their directions, places, all will be calculated. So you have fixed your position with respect to those. And then if you have the need to navigate through a process, through a path like this, your brain would calculate the navigation path and will have a kind of a plan. In air navigation, we call it the flight plan. But I think your navigation planning you are doing every day, even if you move within your house. So a path will be planned like this for you to navigate. Instantly done by the brain, isn't it? So for you to see these objects, first the object should be illuminated by correct light, correct frequencies, then only you can see. The scattered energy from the objects will fall in your eye, and that will be detected by the eye and sent to the brain. And the eye will be picking up the scattered energy. So, you know, there is a visible spectrum, and frequencies within that spectrum will be caught by the eye, and the picture information will be sent to the brain for processing. And the brain will immediately recognize the objects, their distances, their placement. And if you want to navigate, the brain will quickly have the plan, which is like the navigation plan. So since you are doing this position fixing and navigation every day, many times on ground, we will see how this theory applies to the air navigation. So position fix, the word I already introduced. The navigator fixes the position relative to landmarks or other references that you could see. after fixing your position, then you are ready to navigate. It's time to make your next move. I'm still talking about yourself, not about a plane. Later we will relate it. Now, for example, a person like this can see so many landmarks around. And with respect to the landmarks, the person knows where she is. And then depending on where she wanted to go, she can start making the move to navigate. So therefore, we all fix the position continuously and then take navigation decisions according to our navigation plan. But since we have many objects around here, now I have reduced the number of objects here. In this picture, I will reduce further. So to fix your position, you need these objects. Then you know from those objects where you are and how far you are. Suppose these objects are missing and you can't see these objects around. How do you know where you are? Suppose you have less and less support and low number of objects to see, and I think you have been to places like that. It's difficult to fix your position. And imagine without any of them, you lose your ability to fix your position. And navigation will be a nightmare for you. And since you are on the earth and always see these objects, these kind of situations are rare in your experiences. But supposing the landmarks are not there, like you are in a desert, you know how dreadful you feel about it, because you can't locate yourself, you can't fix, and there is nothing against which you can fix your position. Same in the sea, isn't it? And luckily for these people, at least this is there, the sun, so you can fix at least a particular direction. But in general, when landmarks are not around, it's kind of a dreadful situation because you feel like you are without help and you are on your own. And you feel the real loneliness and helplessness in that situation. That's where the ATSEP role comes, especially for air navigation. And when on air, supposing you have climbed to above the cloud base, usually these flight levels, you know, are about 30,000 and sometimes 45,000, around maybe 10 to 15 kilometers, way up. And this is what you see. Sometimes you can't see the ground, and therefore landmarks are missing. Clouds are not good landmarks most of the time. And so that is the situation faced by the pilots. And ATSEP need to help them by giving them navigation support. First, to support them to fix where they are, position fix, and then helping them to make the next move, where to navigate, you have to help. So therefore, we need electronic navigational aids to support the pilots there. These navigational aids are, what they do, they supply the navigator or the control center at an airport, it could be even a seaport, with required navigational parameters. And then these equipment can navigate on behalf of you. Now that you know, if on the ground also, you know, if you need to go very far and you can't navigate your body by foot, actually your mind is the navigator and body is the vessel. So you will be pushing the body, pushing the vessel. If the region you have to cover is a small region, but suppose the region you have to cover is a large region, the distance, then of course you will put this particular vehicle, the body, on another vehicle which can travel far, like a car. And now you know that these autonomous cars are coming into the market, so the car can navigate on behalf of you and take your body from one place to another. The same way, these electronic navigation aids can navigate the bodies of the people or the goods on behalf of them to a given destination according to a particular flight plan. So when you see something like this, Earlier you felt helpless, but when these gadgets are there, these displays are there, a lot of support is provided by ATSEP to the pilot. So these readings on these different equipment, different panels, are really helpful for the person, for the pilot to fix the aircraft position and go along the particular route that he wants to fly. What are these navigational parameters? We need the location fix, position fix, and the speed of motion of the aircraft, and speed of motion of the air as well, and the course details. Course details means the details of the plan, a flight plan that you want to fly. Okay. So these are the velocities, these are the routes and other metadata. So these routes have to be pre-planned and communicated to relevant people. So it's a collective effort between ATSEP, ATC, and Aerocom, and so many different divisions in order to get the flight through. And the pilot himself or herself. Then in the navigation, when we fix the position, there are two approaches, two methods. I'm showing one of them on screen. This is called row theta navigation. And there is another alternative which is called row navigation. So row theta and row navigation are the two methods. And you can see when there is an aircraft, this distance from a fixed location close to an airport, and this angle, which is called the bearing with respect to the north, can be given to the pilot so that he can find where he is. He can fix the position, for which the ATSEP install this kind of equipment. This is called the VOR DME. VOR stands for VHF Omni Range. It's coupled with the equipment called DME, it's distance measuring equipment, in which DME gives the row value, the distance, VOR gives the theta value, which is called the bearing. So the two equipment are co-located, and you can see there are 48 antennas in a circle, because this is a kind of a VOR known as Doppler VOR, based on the Doppler principle. So when this is installed, and usually it is installed close to a runway or aligned with the runway, this is the type of equipment you have inside. So sometimes several cabinets like this. And ATSEP need to take a lot of care when installing and commissioning and maintaining these equipments. You need very highly skilled and trained people to maintain this kind of precision equipment and safety critical equipment. And we have a lot of VORs like this. I showed you one VOR, and you can see this is one. Each of these circles are VORs installed in different places on the ground. And then between VORs, you have these routes at different bearings. And the routes, there are so many air routes, so that it's a kind of a road system, air route system that you have established for radio navigation here. Those routes you can't physically see, but they are there in the sky, given by VOR DME radiation to the sky. For example, in the FIR of Sri Lanka, the flight route I'm showing is between Colombo Airport and Trivandrum. So this is one VOR here, another VOR. You can fly VOR to VOR along a selected, this 298-degree route. And of course, you can change from one location to another like this. And these are waypoints where standard locations where the pilots will normally report when they're approaching. So you can see it's a nice system of air routes drawn in the sky by radio waves. And this VOR DME receiving equipment in the aircraft will help the pilot to follow these routes. So even if he don't have any landmarks to see, these routes are now available to him with VOR DME. So in a primitive old-fashioned display in the cockpit, you have these various equipment where this is VR receiver, then localizer. So many navigational aids, electronic navigational aids to support the pilot. Well, of course, this is very old-fashioned. I just showed you. This is more clear, but nowadays the displays are very different. You find them laid down in a small aircraft like this. Now that even if there are no landmarks around in the en route navigation, now the pilot can use these support systems, electronic support systems, to find his way. And these days you find the head-up displays where you can get any display onto a screen so that you don't need to look down on equipment panel in order to see the reading. Sometimes these equipment panels are now projected to the windscreen as well. And it's coming in the cars, isn't it? The BMWs, the Toyota, they have now manufactured on screen HUD displays, even for the cars. The other one I mentioned is row navigation. I said there are two. Row theta is what I explained earlier. Now this is the other method. Row system, you can easily understand. These could be 3 fixed locations, ABC. And with respect to each fixed location, if you can calculate these distances, row 1, row 2, row 3, and by triangulation, you know where you are. This is where you are. And this may be the path that you want to fly. So in each place, you can keep fixing your position with respect to row 1, row 2, row 3, relative to ABC stations. And these ABC stations could be on the ground, or they could be satellites. So therefore, if they are on the ground, there were systems like long-range navigation system called LORAN sometime back. And nowadays, ABC are actually satellites, because satellite positions are known at a given time. You can calculate row 1, row 2, row 3 to find where you are. And mathematically, this is how you find yourself with respect to row 1, row 2, row 3. So we can we need fourth one because of the clock errors. When you have a fourth satellite, we are ready to do a position fix. And it could be on air, it could be on the sea, it could be in the land as well. So we can write these triangulation equations, and solving of these 4 equations happen within the GPS receiver equipment. Since your phone is also having GPS, this is being done even in your phone. But what is different between the GPS equipment in your phone and that one in the aircraft is the precision. I mean, the clocks have to be more precise and the calculations have to be more precise. That is the difference. Otherwise, the triangulation equations are the same. This is a typical GPS receiver block diagram, GPS antenna. And then GPS is using a technology called CDMA, code division multiple access. So multiple receivers, this is called the rake receiver principle. Each of these receivers can lock onto one satellite, and therefore it can lock onto n satellites parallelly. More satellites you have access, you know, the position fixing will be more precise in the GPS. Okay, so that's about the en route support. The ATSEP support the position fix and the navigation using these 2 main techniques, row theta navigation or row navigation. And in fact, you can have both. You can have row theta and row together, so that if one fails, even you have another. It's kind of fail-safe operation could be achieved. And the other part is the landing. Now, assuming that what I discussed so far is the level flight, the en route navigation, and then the more critical one is the landing, for which you have different kind of support. If everything is clear, there is visual landing possible for the pilot. But in adverse weather or at night, you need a lot of support given by ATSEP. And you have systems called instrument landing system, ILS. And there was one called microwave landing system. And now new ones coming called ground-based augmentation systems, which I will quickly go through. In the ILS, we have these kinds of equipment by these names: localizer, glide slope, markers. They are installed. I'm giving you the plan view looking from the sky, assuming this is a runway strip. Then you install one equipment called localizer here. And this is the antenna, this is the equipment. And another one called glide slope and the antenna. And markers, markers, inner marker, middle marker, and outer marker. Nowadays, inner marker is not compulsory, not needed. And this is the extended runway center line. At given distances, you install these markers. So these three subsystems put together, we call instrument landing system, and that gives landing support to the pilot. And also you have the visual support called precision approach path indicators, sometimes called visual approach indicators. They're also there. In the vertical plane view, if this is a runway, the markers are like this. Markers radiate upwards, certain beams like this. And when the pilot is, when the aircraft is crossing these beams, he gets an indication, a proximity indication of how close he is to the runway threshold now. So the flight approach path will be typically around 3 degrees to make it convenient to the passengers. And proximity indication given by this received signal during this period, then during this time, then during this time. So since the time is limited, in the presentation I have included the videos if you want to get more details about this. Okay. So he will hear certain tones when he crosses these markers, and also he will have some lights, so visual indication as well. And those are markers. If we come to the localizer equipment, localizer is antenna array and equipment installed here so that it will help the pilot to align the aircraft along the extended runway center line, even at night, and even if there is no visibility of the runway. So it radiates beams like this with different names like sideband only, etc. Technical names I will avoid. And there are 3 main beams. In fact, there is 6. There is another 3 called clearance beam, but I will show you only the 3 main beams. And using these signals, they are picked by far away by the pilot. And using these signals, he gets an indication of how offset his approach with respect to this runway center line. He can catch this signal at about 50 to 60 nautical miles away from the runway, and he will get fly left or fly right indication on the display, and he can follow the needle. If the needle says go to the left, he just fly left to align with the extended runway center line for landing. This is fly right indication, fly left indication in each sector. Let me show you the localized antenna, which is at the end of the runway. So these are the antennas. So it's an array of antennas driven by RF signals. This is another installation of localizer antenna. Another installation of a localizer antenna. So this is at one end of the runway, and if you support landing from both ends, you will install 2 localizers, one at each end. Okay. So in clear sky, first the pilot can see the runway, and problems occur when it is cloudy or when there is a lot of fog or mist or heavy rain, so that the cloud base has come down and the clearance between the ground and the cloud base being very small, the visibility becomes very poor, and there is a lot of risk during that phase, especially in bad weather and night. At night, of course, you will have this visual support also with the lighting. So you can catch the glide path signal at about 18.5 kilometers away from the airport, and then you can glide along that, catch the localizer, and then you can glide along that glide path. But of course, you have to catch the localizer first and establish on the localizer, and then come along that. And when you get closer, you will be able to receive the glide path signal as well, and then you can descend. This is the glide path antenna, the shelter and the antenna. Shelter here. Usually 3 antennas, we call it M array, and that is installed by the side of the runway. So this is the runway. When you go along the runway, you can see the glide slope by the side of it. What it does is, using this kind of an antenna array, it radiates certain signals. These are the mathematical equations of those signals, and they combine in the sky in order to form this kind of radiation pattern. You have the glide angle, which is about 3 degrees shown here, and you have one signal dominating below that and another signal dominating above that. And therefore, the pilot will get fly up indication if he is too low. He will get fly down indication if he is above this line. So when he has received the signal, he will continuously get fly up, fly down corrections from this ground equipment. And the accuracy of this equipment is very, very important because my small error in the landing could be fatal. The reason being that at certain heights, it may be, the pilot may not be having enough thrust to take up the plane again, climb it again. Therefore, these are very precision equipments. New systems coming up these days are called ground-based augmentation systems. I mentioned GPS earlier, and based on the GPS, landing systems are coming up. Landing support is coming up now. What it does is a technique like this. You have these GPS satellites. They are called global navigation satellite systems. And then there are fixed reference receivers close to the airport in a known location. So then received signals from each satellite is received and position is calculated. And there is a correction calculated because actual position is known in this ground station. Calculated position minus the actual position is the position error in this region. That position error is going through the GPS system and transmitted to the aircraft so that the pilot, the cockpit equipment can receive direct from the satellite like this, plus this correction. So using these 3 inputs, it can calculate its position, and then using this input, it can correct it if there is any error. There is a little error usually. Without correcting that error, the precision is not enough for landing. Therefore, you install these ground-based augmentation systems, especially close to the airports, so that the GPS system will have enough accuracy to give the landing, produce the landing, support the landing. User means the pilot can apply these corrections that will be happening automatically within the GPS receiver. Then accuracy depends on the distance between the user and this differential GPS equipment. This is one implementation in Sydney. You can see the ground-based receiving systems, and in this near the vicinity of the runway, any position errors will be corrected by VHF broadcast, giving the correction from this station. Then aircrafts can receive direct from satellites as well and keep on calculating their position. Plus, aircraft can receive from this VHF broadcast that correction. So keep correcting and increasing the precision of the predicted position of the aircraft, and that is good enough for landing. So these systems are being installed worldwide now. ILS is a very old system. Actually, it has been there in use for a very long time now. And this system is supposed to take over the ILS in the future. You could see how much of support is provided by the ATSEP to the aircraft by looking at all these antennas. What are highlighted here by arrows are different support systems from the ground giving signals to the aircraft, and all that is supporting this electronic navigation. So the equipment I mentioned earlier, DME antenna, you can see here. GPS antenna, you can see here. Weather radar antenna is here. The glide slope antenna I mentioned earlier, that's installed here to receive ground support, ground equipment signals. And for communication, VHF and HF. Then VOR antenna I mentioned, that is installed here. So you can see so much of electronic navigation support is being provided to this vehicle. Okay, in a heads-up display, this is how you see when approaching. Now this pilot has aligned himself in the localizer. So he has aligned himself with the extended runway center line, and he has started his descent. And since this is a crucial phase, head-up displays are very useful because the pilot has a lot of work to do and may not have enough time to keep on looking down for equipment. So the new generation displays will be like this, appearing on screen. And these alignments also could be done on screen. Okay, so all that is about the navigation. So you can see when the position fix is achieved, then you have the flight plan and continuous support until you descend. And even descending, and then in the final approach, you have a lot of electronics equipment supporting each phase of navigation. Then when it comes to surveillance, that's the key area. This is your eye, and it's an antenna which receives certain frequencies, focus onto a screen here. And in that screen, you have a lot of sensors, and those sensors will take biometric signals to the brain. Signals are generated by the retina by these gadgets. So we need to, this is a biological eye, and we can make something similar to this to see through. Actually, the biological eyes, you know, they can't see through the clouds, they can't see through the walls. But if we use a different frequency, we call radar frequencies, they are microwave, they can go through the walls and see through them, and also see through the clouds. And ideal for detecting the position of the aircraft by the ground stations. And you have something similar to the eye, you can see. This is the sensor equivalent to this, the retina. And this is the focusing lens, which first radiate a pulse and then catch the return echo into this receiving, and through these cables it's taken down. In this case, it's taken to the brain. Same way, it is taken down to a receiver and the brain. Brain is the radar processor. You can see how the technology has been adapted from biological, but this is not as superior as a biological sensor, but it it can see through. That is the main advantage. And it can see very far as well. You can see hundreds of kilometers. And you have two kinds of surveillance equipment. This is primary radar, and this one is called secondary radar. Secondary radar can communicate with an equipment installed in the cockpit, and so the two equipment will coordinate. But primary radar does not need any coordination from any equipment from the cockpit, and for primary radar on its own can detect where the aircraft is in the sky and fix its position. You see, when you are seeing objects, let's say this particular insect is being seen by you, then you know these antennas, they pick up, and then there is a cable taking it to the brain, and brain does the visual processing here, visual cortex. It will identify the shape and make the shape purified and put on the color, and finally identify which kind of insect it is. So a lot of processing happening within the brain, and we can do the same using electronic processing systems, which we call the radar processor. So this brain here, your brain is equivalent to, in this particular role, is like this. In this is inside of a radar station where you can see the transmitter, receiver, and the radar processor as well. And that processing part is the brain. So this way, the ATSEP people can find out where the aircrafts are in the sky using this radar processor, and put it on display for the air traffic controllers so that they can help and they can give the instructions to the pilots. So what is processed by the radar processor may appear on screen like this. Each aircraft is appearing like a blip. Of course, a lot of processing needed to remove the ground clutter and cloud clutter from the radar screen. Finally, you can get it up to this level. But for the aircrafts to maneuver properly, you need the support of a human brain. And therefore, this is given to the air traffic controllers. And their brains will also support this decision making. And the air traffic controller and the pilot can talk to each other and then make decisions about the maneuvers. So you can see these different blips, they are aircrafts, and their history is given here. And of course, their predictions, future maneuver can also be predicted by the radar brain, radar processor. And then that is the basic radar. In the secondary surveillance radar, you transmit to the pilot, not the pilot, actually cockpit equipment, and interrogate the cockpit equipment, asking questions like, who are you? What is your altitude? That kind of questions. Then the equipment will automatically reply. You don't need pilot to intervene there. Equipment will automatically identify, this is my code and this is my altitude. That kind of information will come to the ground. And that's also very useful for the air traffic controllers. Then surveillance enhancements have come up. There is this collision avoidance systems using secondary radar, and then mode S equipment. And based on that, you have ADS, automatic dependent surveillance, which has different modes, mode A, mode B, likewise. You can visit these kinds of websites to see the videos there. They are all enhancements, and they have gone a long way now. They have come up a long way. Especially this ADS, automatic dependent surveillance. It helps aircrafts to automatically exchange data with ATC using a data link without pilot intervention. So that makes the job of the pilot easier. and transmit the aircraft position and the flight plan during oceanic crossings. And you may use for that transmission data links such as satellite links or HF data links. This is ADS-A mode. Right? An aircraft should be equipped with this flight management system CDU facility like this, which to receive those messages. And therefore, without asking by voice, it's very easy to communicate with the aircraft using this facility in text, because voice communication, you know, these pilots and ATCs are from different regions of the world and their accents are different, speaking is different, there's a lot of challenges. But whereas when you pass messages through ADS, they are more reliable. Such misunderstandings are very unlikely to happen between this equipment. So this mode A will use ADS. Mode A is called address mode, and it uses data links like this. Mode S could be used in the SSR, secondary surveillance radar, or VHF data link could be used. You require a cockpit display. ADS-B has become very popular because it allows the pilot to see accurate depiction of real-time air traffic in the same area as the controller. So both controller and the pilot can have similar information, and that is very easy for coordination, and misunderstandings could be minimized using this. So it will use cockpit display of traffic information called CDTI. ATC will see the information on their regular ATC display, which is normally much larger, and the pilot can see a view like this. What are the aircrafts around with their identities? So it's very easy because both pilot as well as air traffic controllers see similar kind of information, and the understanding will be much better when they talk to each other. Then this ADS broadcast unit will broadcast the GPS position via a digital data link along with the other data like airspeed, altitude, whether the aircraft is turning, climbing, descending, all that information could be transmitted. So anyone with the ADS-B equipment, these ADS-B equipments are very small and lightweight, anyone can receive and view it. It works at all altitudes, even on the ground it works, so that you can even monitor the traffic on the taxiways, monitor runways. So monitoring has become much easier now. It can also detect any conflict in the flight plans. Resolution could be pushed there. Photos of ADS-B equipment, and it's becoming very, very popular now. There are frequencies 978 megahertz and 1090, and 1090 has been adopted as international standard. We call it ES, in extended squitter transponder. Well, you can use these links to check, like now ADS-B signals you can receive on your computer through internet and receive the links, receive information about places of each aircraft. Let me see whether this link will work. If it comes up, I'll share with you. It's available to the public. This is what I received through that link. So you can see the aircrafts related to the Colombo airport at this very moment by the aircraft identity and where they are with respect to Sri Lanka. And this is available in many airports now, inbound and outbound flights, their positions, publicly available now through this marvelous technology called ADS-B. Okay. Let me share the previous one again. So from any place, let's say Heathrow. And you can see here all flights related to Heathrow Airport at this very moment. You know, Heathrow is very busy and so many inbound and outbound aircraft there. You can zoom in to get more precision information. Like this, you can see aircraft being maneuvered even. When you zoom in, you can see their track, their history. They are maneuvering, like turning, everything could be seen there. So these are available to the pilots and air traffic controller, and also available to you as well as general public now. So you can see how far the surveillance technologies have gone now. Let me go back to the presentation. Let me close these windows. Okay, hope you are seeing the presentation again. What I showed you is ADS-B output and its capabilities. Then the third main area, the communication area, what we have just finished is the surveillance, in which I highlighted the primary radar, secondary surveillance radar, and the enhancement of secondary surveillance radar like Mode S. And then we discussed extensions like ADS, Automatic Dependent Surveillance Mode A, and Automatic Dependent Surveillance Mode C, Mode B, sorry, broadcast. So surveillance have developed by leaps and bounds like this. Then the third key area, communication, it has been there all the time, you know. For communication, traditionally, HF frequencies, high frequencies have been used, and VHF, very high frequencies, have been used for voice communication between pilot and the air traffic controller. But communication has come a long way now. In the CNS concept, now what I talked is summarized here actually. You can see the GNSS satellites and ADS-B. So each aircraft equipped with ADS-B can follow. And air traffic management, I'll come to that in a moment. And you can see these links. You can see these different links and coming to a telecom network, and through the IP networks on ground, the worldwide information could be shared here. That's the advantage. So voice communication, you know, is being limited to line of sight and also limited to the range of the HF, and the quality of the HF there are limitations, but whereas once you use these data links in between the aircraft and the ground, they are, more reliable, and also they could be easily distributed worldwide. So that development has happened, and many communications have switched to the IP based communications. So especially to mention that now there is this data link called CPDLC, which is controller pilot data link communication that gives data exchanges in addition to this voice communication. So you can see two kinds of communications are like supporting each other during communication between pilot and the ATC. A more summarized figure here, less cluttered figure, you can see CNS user here, and he gets support like this, and then he can relate position calculations to the ground-based ADS receivers and GBAS stations, and they are all networked now. All these are networked, so that information can be shared very quickly. So communication has improved drastically with this data communication links being established now between pilot, between cockpit and the air traffic controller. And this is the way it has. It will appear now. You have the ATM, and also you have this flight data processing. Flight data being processed and flight data exchanged through these local ground communication networks. Okay, so air traffic management means putting all these input together. What are the different inputs? You will be getting inputs from each radar. Supposing there are 2-3 radars. Each radar will be detecting certain portion of the sky, and some aircraft will be detected by more than one radar. And all that information will have to come to ATM, Air Traffic Management System. And plus the flight data will also be received. Plus the communications, data link communications will be received. And all of them will have to be tallied, verified. And once verified, once the data is verified, they will be put onto the display. Of course, depending on the amount of validity, you can change the color, you can change the icons, so that controllers will easily see validated information, less validated information, and unvalidated information separately. Well, this is a message handling system. It is a worldwide system handling all these messages of exchanging flight plans, etc. Earlier, it was called AFTN, Aeronautical Fixed Telecom Network, and every country or every airport will be receiving or contributing to this, now known as message handling system, and slowly becoming IP-based worldwide system through VPN technology. And these IP-based ones are coming up with new protocols, similar to email protocol. They have now P3 protocol, specially designed for exchanging these messages between airports. And putting everything together into ATM, Air Traffic Management System, what I showed you a moment ago is flight data processing system. Okay, and in ATM, Air Traffic Management, you will have all things, inputs coming from radars. Radars, you know, could be IP radars or ADS-B. All that information will come to servers. serial radar informations will also come, and ADS contracts and CPDLC will also come to these servers. And they can provide the air traffic management information to the controllers. And on the other side, this AFTN related worldwide messaging system related to aviation, which is also called now this message handling systems. They are integrated into a flight FTPS system, and that is separately available for aeronautical comm officers for their work. So all this you can see all this is communication. Through communication, you gather a lot of information, and then you put everything together for validation. Once these servers validate the information received from multiple sources, validated ones will be presented to the air traffic controller as well as Aerocom AIS officers so that their decisions may be well supported by these communication and management systems. So you can see the communication also has come along a long way, developed a long way, and slowly changing from voice to data communication. And in data communication also, it's slowly changing to IP-based systems now. Okay. This is the display ATM, air traffic management display, and you can see these different colors. They are routes, waypoints, and where each aircraft is. And these blips, the message could be expanded to see individual information if you want to. But this will provide a very concise and validated information for decision support for the controllers. Right, so that is the communication part. I think within the available time, I try to finish the CNS leading to air traffic management. So we have covered the navigation part and surveillance part and communication part, and their integration into air traffic management system. Now, all this you can see are highly precise electronic systems coming up, and they are networked now, and you need very specially trained, skilled people to ensure their safe operation. And that is why the ATSEP is, the role of ATSEP is becoming so important now. And because the decisions taken are heavily supported by these equipment which I described. And I think you are aware this is safety critical industry, and you know how important it is to make very correct decisions in these burdened skies. Nowadays the skies are becoming more and more burdened with a lot of traffic. Just like the ground traffic building up, the sky traffic is also building up, and therefore you need more sophisticated systems with fairly automated decision making. So part of the automated decisions could be handled by the electronic equipment in the future. Okay, so with that, I think I would finish my presentation. I think I have done justice by trying to give the whole lot of information which I cover within one semester in 14 lectures in the university final year into 1 hour. I don't know how successful it was, but I think you got some idea about the kind of support given by these electronic navigation systems, communication systems, and surveillance systems, and how much of decision support they are giving. I think you may be aware by now, and how important the role of ATSEP to ensure the safe air journey for passengers. I think you would have got a good idea. So with that, I will stop my presentation, conclude my presentation, and thank you very much. We can move on to question and answer sessions. I think there are some questions coming up. Well, so here I conclude my presentation. Thank you very much. Thank you all.
Thank you very much for the fruitful talk, Mr. Kithsiri. It really was a wonderful session. So please send your questions to Q&A on the chat. You can use both Sinhala and English. So before that, let's go for a video.
Taxiway Alpha to holding point runway 22. Sri Lankan 139, give way to Emirates point 777, taxiing on parallel taxiway left to right.
400, estimate pickup 1425, and estimate depot 1440, confirm. Pleasure, plan the plan of this frequency.
due to the technical difficulties occurred in the previous session, I would like to invite Mr. Priyantha to deliver you about the role of ATSEP.
Good afternoon, ladies and gentlemen. Good afternoon, Engineer Samarasinghe and my colleague Chandana. It's a privilege for us to have Engineer Samarasinghe in the evening for sharing his valuable inputs for today's program. Since his past experience in the Electronics and Navigation Engineering Division of ASL as an electronic engineer. As introductory videos, messages delivered by the ATEOA today has been declared the Day of ATSEP internationally. ATSEP. What is this acronym ATSEP stand for? Who are they? Why they are special to aviation? And these might be the questions you might have right now. So I'm going to brief you on these topics with a limited time slot. And before I reach you on the subject of ATSEP, I'd like to brief you on related terms first. Flight information region. Each country has its own airspaces, as you do have your own residential boundaries. CNS ATM in aviation. I'll explain this acronym from different contexts. In the medical world, CNS is the acronym for Central Nervous System that is vital for sustaining life. And so in sense, it's the same in the aviation world. Today, with thousands of aircraft aloft at any one time, communication, navigation, surveillance systems, that is called CNS systems, as described by the engineer Samarasinghe in the previous sessions, plays key functions to provide the required form of infrastructures for air traffic management, ATM. That is to improve flight safety while more efficiently utilizing available airspace. Maintaining clear communication for ground to air or air to ground operations, and maintaining accurate navigation system, especially for homing, and maintaining precise surveillance system for locating aircraft have long been important for safe, efficient flying. So you might understand how important CNS service combination is required for air traffic management, and that is for safe flying seamlessly across boundaries and terrains. Or you might understand how flying is safe in the absence of CNS platforms. Air traffic safety. Ever-growing aircraft movements are continuously limiting the capacity of airspaces, which are congested day by day. This has been a key challenge faced by the global aviation industry stakeholders since skies become more crowded and one of communication, navigation, and surveillance become a limiting factor for air traffic management. It is inevitable for safety risks, and therefore efficiently use of airspace despite catering to growing demands has to address at any cost. Understandably, this challenge can only be met with the continuous evolution of or development of CNS ATM system technologies. Managing and upgrading CNS ATM systems in timely and precise manner itself enable aircraft operators and air traffic controllers to meet their planned times of arrival and departure or adhere to their preferred flight profiles with minimum constraints without compromising other possible safety risks. Now time to come to the key topic, ATSEP and their role. Air navigation systems have been implemented and operational globally and go beyond geographical boundaries. So the role of CNS ATM technical expertise has been highlighted from common technical categories and acronym as ATSEP, Air Traffic Safety Electronic Personnel, by the International Civil Aviation Organization. So ATSEP, Air Traffic Safety Electronic Personnel, is described as unique technical and engineering professional, proven competent in planning, installation, calibrations, operations, and maintenance of air traffic safety electronic systems. This includes communication, navigation, surveillance, and air traffic management systems in other words, CNS ATM systems. So these things has been described by engineer Samarasinghe previously. So simply ATSEPs are personnel who install, maintain electronic safety systems for air traffic management. ATSEP performs tasks on a wide variety of CNS ATM systems and equipment requiring a wide range of competencies and expertise, as well as knowledge and skills in engineering activities. And they are related to system installations, project management, specifications, conceptions, testing, acceptance, safety assessments, and upgrading or supporting electronic systems. Equipment and systems explained in the previous sessions. As described by the previous session, has gone through these milestones. For youngsters in this forum, if you are willing to become an aviation professional, so don't forget to search the term ATSEP. Regulatory requirement for competency and skills building for ATSEPs. The effective performance of air traffic management depends on competent and qualified air traffic management professionals. So ATSEPs has shared understanding in terms of performance when considering the growing complexity and interconnectedness of the system involved. Considering the role that ATSEP play delivering a safety and their place in the safety chain in the aviation and growing complexities of the air traffic systems, there is a need to minimize the risks that exist with the technical systems. Therefore, ICAO has developed several manuals and guidance documents to support skill developments via competency-based training and assessments. This is also standardized and bring ATSEPs all around the world to uniform global level and rate competency and skills with licensing. This has been focused to minimize various training standards and implemented by the individual states. Controller pilot, a system-to-system interfaces evolved. The air traffic safety electronic personnel managing the entire backbone functioning of the CNS ATM engineering infrastructures in compliance with the International Civil Aviation Organization standards and their recommended practices in silent and behind the screen role. Now I want to emphasize the role that played Sri Lankan ATSEPs. So in Sri Lanka, all ATSEPs are under the Electronics and Air Navigation Engineering Division of the Airport and Aviation Services Sri Lanka Private Limited. The task has been assigned in various geographical locations on the island, depending on the strategically located CNS ATM infrastructures, which is required to support the provisioning of air navigation engineering services to cover the entire Sri Lankan airspace. Electronics and Air Navigation Engineering Division has branches out 9 subsections achieve the above task. Communication Engineering Section, Ratmalana. To facilitate for Sri Lankan airspace, control activities and coordination with the neighboring states by employing communication and surveillance systems and other infrastructures is their main objectives. This section also catered to aerodrome activities of CI Colombo International Airport, Ratmalana. Electronics section, Bandaranaike International Airport. Mainly provisioning of CNS infrastructures and services for international airport operations and linking with the ACC services, Area Control Center services. They also involved in aviation meteorological systems and passenger security screening system in the Bandaranaike International Airport. Radar and Communication Center, Pidurutalagal. This section provisioning the extended rate VHF communication. This has been coverage beyond 250 nautical mile for communication between aircraft and air traffic controllers. In addition, this site provisioning of radar and ADSP surveillance coverage for our FIR. The other section is the HF transmitting section Athidia. As described earlier, providing HF coverage, especially for oceanic part of the FIR. And HF receiving section, which is located at Kandapala, Nuwara, for covering HF reception from aircraft. Electronic section, Mattala International Airport, for the mainly provisioning of CNS infrastructures and services for MRIA operation, including security screening systems. ENA electronic section, Batticaloa International Airport, provisioning of communication infrastructures and services for Batticaloa aerodrome operations. Electronic sections, Jaffna International Airport, for provisioning of communication infrastructures and services for Jaffna International Airport aerodrome operations. Research and Development section, Ratmalana. That is for infrastructure supportive activities to maintain above sections. In addition, we have 2 ADSB surveillance coverage sections, which is located at Kilinoche and Suryakanda. We have NAYAB at the remote radio relay station, which belongs to Sri Lanka Telecom. In addition, communication infrastructures, interconnections which have been outsourced from different telecom service providers. This is the summary of ATSEP and their role in aviation. So CNS ATM systems installed in above sections were briefly described by the previous session engineer Samarasinghe. So I'm in completion of this session and hope you have a picture about the ATSEP and their commitment to the global aviation. In conclusion, finally, I must thank Air Traffic Engineering Officers Association Sri Lanka, who is the only ATSEP association and representative of Sri Lanka to International Federation of Air Traffic Safety Electronic Association, for this wonderful effort for organizing this knowledge sharing event in meaningful way to celebrate the International ATSEP Day. The Air Traffic Engineering Officers Association Sri Lanka has shown their professionalism and commitment to the aviation, especially in the supporting to the next generation aviation professionals, which was an initiative launched by the International Civil Aviation Organization. This is also to promote youngsters to become qualified and competent aviation professionals to maintain future international aviations. Finally, I wish to remind ATSEP professionals ranging from air traffic safety electronic engineering officers to engineers and senior engineers and head of divisions, those who are in and out of service for their invaluable contribution and services to the aviation. Thank you.
Thank you, Mr. Priyantha. So without any delay, let's go for the Q&A session. Mr. Kithsiri, Mr. Maddumabandara, and Mr. Priyantha will join with you.
In some questions I can see. Shall we look at one by one? There is one question about UAV. What is the technology to maintain the controlling communication between UAV and the ground controller? What type of antennas we use for them? Well, for the UAV, the controller link is mostly personal, and that free band 2.4 gigahertz and 5.8, those are the bands they use. And the antennas are very small, you know, those being microwave. Small antennas, lightweight, and usually wideband antennas they use. And actually they use two links. You have one link for controlling the vehicle. The other one is for the video. Whatever the data feed will be the other one. So sometimes these two frequencies are one in 2.4, the other one is 5.8. Or sometimes they could be in the same band. And that's how the UAV technology goes. But you know, UAVs are sometimes for personal use, but some of the UAVs can fly very long paths, and even without communication. And their path can be pre-programmed so that they return automatically to the sender. For example, those UAVs developed by the University of Moratuwa department, they can fly anywhere in the country. You can pre-program, so they will fly, deliver, and return through satellite links without communication link with the ground. Video could be recorded and later downloaded. Those features are there. But you know, this UAV technology is reaching now, I mean, globally. You can fly. If a particular country has its own satellite system, that country can maintain satellite links with the UAV and get the UAVs from anywhere to anywhere in the world. So that's how that technology is being developed.
So do you have any other questions?
There is one more question asking, is there specific antennas to use over 100 kilometers? Actually, these are over the horizon communication. We call it OTH communications, and you have two modes. One is HF, skywave communication. The other is low frequency communication, LF mode and VLF mode. For example, the LoRaN system I mentioned earlier is operating around 10 kilohertz, and antennas are so large, very large, but they can go beyond 100 kilometers. Of course, I forgot the satellite technology, and that can cover globally. So therefore, in fact, there are three. This VLF, then HF and the SATCOM. Malit is asking, are there any initiatives by universities to develop UAVs for flight inspection exercises in Sri Lanka? Actually, Malit, to my knowledge, for flight inspection, UAVs are actually not being developed at the moment. The ones developed by our department are mainly used for surveillance, like police, Sri Lanka police is using, and survey department is making use of that, and but not for flight inspection actually. Well, flight inspection, in fact, need a lot of precision equipment. I think you need a fair amount of investment on that. Well, there is another question. It is about the reliability of the GPS. Whether GPS is, well, whether it is safe to use GPS, that's what the question asks actually, because of this political issues. I mean, GPS could be shut down by a country owning a particular satellite system. So those issues, in fact, I have not closely followed those recently. I may not be the best person to answer that. To my knowledge, what is being tried by the Civil Aviation Organization, ICAO, is to have a global navigational satellite system that they call GNSS, which is kind of a combined effect of three main systems, that is GPS by US and Galileo by the Europeans and GLONASS by the Russians. So GPS equipments are supposed to be made in the future for navigation by which can receive at least from two of these systems. So that if one country decides to manipulate it, still the users have the choice of using the equipment with the other. So that kind of attempt I am aware, but other than that, I think other officers in ASL might be able to answer better. Chandana, will you be able to?
Something I couldn't follow. I had some technical problems with my computer, and please describe the question again.
The question was about whether using use of GPS, because it belongs to one country, whether it will be good, I mean, whether it is reliable, I mean, whether the owners could manipulate the signals and that kind of question.
Yes, now the answer is, I think, was with your lecture now. If you use the ADGPS-like thing, we can use that correction signal and we can avoid that manipulation in some extent, no? I think he's asking about these errors and all.
Not about errors. I think it's about like purpose, willfully manipulating signals. This is what I will read the question. Why this is how he has asked, why some of the countries don't like to adopt the satellite-based navigation technologies. I have heard that the satellite data can be manipulated. Is that true? Would you please clear this problem? Mr. Nimal is asking.
Yes, actually, Mr. Samarasinghe, as you said, that kind of manipulation we can avoid with some kind of correction. No, if purposely someone is trying to manipulate with the ground-based known locations. Actually, at this moment, ASL we don't use those kind of things. We only use ADS-B and ADS-C in connection with the satellite at this very moment.
Yeah. Correct, Chandana, yes. Because you know the location beforehand,
Yes.
the signals are manipulated, you would know as well.
Yeah.
So GBAS systems will not be, will immediately avoid using manipulated signals then.
Yes, correct.
Yeah.
With the non-location information.
Correct, yeah.
And there is another question, Samarasinghe, is stealth technology being used in Sri Lanka by ASL? Up to now, no, we don't have any stealth system in ASL.
Okay. Yeah. VHF, one more question says, VHF comms are not secure. Anyone can transmit to an aircraft. Are there any emerging secure communication techniques for aviation use?
Yes.
I think Chandana, you can answer that.
Yes, up to now, we have been using conventional VHF communication with aim modulation techniques. As he said, it's correct. If can manipulate, then we have those kind of problems. Some pulse transmission, and we are receiving from outside, and we can't get rid of them. So we can, if the technology is coming for digital communication schemes, like with some digital modulation methods, then we can avoid this. But still, we don't have such systems. But I think in the future, they will definitely come to get rid of these kind of problems. I mean, this VHF normal analog communication problems.
Okay, and Mr. Athletic has asked, do you envisage conventional ground-based navigates being phased out in the near future?
Yes.
Well, are there any deadlines in the migration plans, which I'm actually unaware?
Yes, there are some new technologies to come up, but there are some deadlines posed by the ATEOA as well. But we are still relying with the old systems. We have some problems with procuring and all, but in the future we'll come up with the systems like D-bus, NS-bus, and all.
Well, Tarak is asking, where is the radar situated in Sri Lanka? Chandana, you can.
Yeah, our main radar is in the Durutala Agland. The other one is at Bandaranaike International Airport. And Mr. Chandana, there is another question. If somebody likes to learn aviation communication, what are the recommended course of opportunities in Sri Lanka? I think this Varna is asking, he can contact Civil Aviation Training Center. There are many good courses related to aviation. I think some outsiders can also have participated. He can inquire from this institute. This at Ratpanala.
Okay, is it available to general public now?
There are some courses,
Okay.
not all.
Right. Okay, that's great, I think, yeah. Prasanna has sent one question. First, thanking for the previous presentation, but I would like to know whether all the three systems, whether they are now developed to reach full autonomous flying from A to B. Well, theoretically, yes. I mean, full autonomous flying is possible, but practically, when carrying passengers, there are a lot of certifications, safety certifications to go through. And therefore, for public transport being automated, it will take some more time. But deliveries, goods and all, I mean, autonomous flying, is now possible.
But not the passengers fully now.
Yes, not the passenger flights.
So there's a question for you. I think so. You can you suggest a book or article to refer for UAV antennas and communication?
For UAVs alone, I didn't see a particular textbook. I think best person to contact is Professor Samarasinghe of Department of Electronics and Telecom Engineering. He would support a lot, I think, for anyone who is interested in UAV. I would like to suggest you contact Professor Samarasinghe. He is an enthusiast and also a great supporter for anyone who wants to learn that area. So you can use the website to find the number and get in contact with him. He's the one who developed the UAV.
Malik, what are the plans in place of certifying professional ATSEP in Sri Lanka? Yes, yes, this is a necessary things to be planned, and we haven't still initiated it. For this, we need to have a collaboration work with ASL and CASL. The answer is we haven't initiated it yet.
Could you have any other questions?
Well, I think there is a comment by Jananath. He says, we just rebranded our workshop section as R&D. It's done with the intention of designing some possible systems within Sri Lanka, as Malit requested in a previous question. When possible, let's do it with the collaboration of universities. I think it's a great initiative if we can strike that. Because even the UAV project initiated by Professor Samarasinghe started small like this with the same intention, and it has gone a long way now. Several different types of UAVs have been locally developed. So yes, of course, you can contact the department here or even the Peradeniya. We would like to collaborate. So let's talk about it later, right? Thank you, Jananath, for the actually suggestion even.
I think we have a question from Samadhi.
Okay, by an undergraduate.
Yeah.
Well, I think he's asking about the recruitment joining aviation field, asking why, whether there are any chances to join the Air Traffic Engineering Officers Association in future, and can you explain the path for it? Well, recruitment path, I think if one of you explain, it's good. Priyantha.
The question raised by Samadhi. They asked the join the Air Traffic Engineering Officers Association. Actually, this is an association which comprise members of ATSEP, those are employed in the Airport and Aviation Services Sri Lanka Limited. So employees who are ATSEPs are the members in the organization. So I think you are answered what you wanted to know.
So do you have any questions? We have a few more minutes.
I can add something to what Samadhi has asked. Now he's an undergrad and very interested in joining aviation, it seems. I can recall I myself was also like that by the time I passed out. And Airport and Aviation Services helped us by recruiting us and training, giving training, and lot of support was given to us to develop ourselves in that area. And so I think you can wait for the advertisements and apply after your graduation. The recruitment process is a bit longer than other organizations, but it would be very worthwhile experience. I myself can certify that because I have gone through it. That's what I can add to Samadhi's question.
Yes, sir, we have a question from Taranga. He's asking, is there
Yes,
any...
sir. Yes, he's asking, is there any ongoing process? Yes, we have planned to implement in the future space-based ADSP. And I must say that I 100% agree with Mr. Samarasinghe's idea about the ASL. This is a very good place to learn and to work. And I think his advice to that Samadhi is 100% correct. And so I remember that when you were here, that was the time we joined ASL. And we had very small period with you here. Actually, ASL is a nice place. I 100% agree with you.
Well, there is one more question. I can see how some systems are used by all the aircrafts flying in Sri Lanka at the same time. Well, the sharing systems we call multiple access. For example, equipment like DME, they have a limit actually. I mean, number of aircraft that could be simultaneously served. Due to that multiple access method, if I remember correct, it's about 100 aircrafts at a time, but we don't have that much of traffic.
That much of aircraft, yes.
Yeah, but some equipment may have limits like this, but many others are like radiated to open air and unlimited number of users can use. Like, for example, VOR. I mean, any number of receivers could be using it. They are just broadcasting. Therefore, there is no limit for multiple access for such equipment.
There's a question from Nisal. He's asking how same systems are used by all the aircrafts flying in Sri Lanka same time.
I think Mr. Samarasinghe answered that question earlier.
Ah, okay.
Yes.
Okay then, thank you all. We have a wish from Mr. Senthil Balasubramaniam, Asia Pacific Regional Director from Air Traffic Safety Electronics Association.
Good evening to all of you. It gives me great pleasure to join you on International ATSEP Day. I would like to appreciate the efforts taken by Air Traffic Engineering Officers Association of Sri Lanka and give my best wishes for their Zoom webinar on Story Behind the Safe Air Journey. No story can be told without characters. And when we tell the story that is not known, not only we need orators, but characters themselves. I see my dear friend Mr. Priyantha is one of the speakers for the evening. I am sure the other speakers also will help in revealing the heroes behind the safe air journey. Why these characters are unknown to the common passengers? Because we take over from the gate closer to the gate opening for ensuring your safety. We are invisible but follow with the safety bubble like a shadows even in the dark throughout your flight. In fact, we start our work much before you book a flight. We give visions to pilot, tools to air traffic controllers for ensuring the safe and orderly flow of the air traffic. We are entrusted with the implementation of all the ground infrastructure related to these tools. Further, I would like to leave to the speakers to reveal more. Sri Lankan ATSEP and office bearers are our favorite collaborators. I wish you all the best. Once again, a very happy International Day.
Yeah, we have another wish from Mr. Thorsten Way, President of International Federation of Air Traffic Safety Electronics Association.
Dear Mr. President, Executive Board and members of the Air Traffic Engineering Officers Association of Sri Lanka, for your assembly I wish you all the best. And just to give you a small overview, ATSEP is the global voice of air traffic safety electronics personnel, and our intention is to continuously improve the regulatory framework with ICAO. The last very important step was to establish the ICAO Doc 10057 competence-based training document for our profession. I wish you all the best for your assembly, and do not hesitate to contact ATSEP if you need any support for your association. And again, I wish you all the best. My kind regards to all of you, and I wish you all the best. Thank you very much.
Okay, I would like to invite Mr. Yasuru Karutranti for the vote of thanks.
Thank you, Nwandi, and hello everyone. Air Traffic Engineering Officers Association of Sri Lanka organized this webinar in order to share information about the profession of ATSEP, and I hope that you all enjoyed the session. First, let me thank Mr. Kithsiri Samarasinghe, Senior Lecturer of University of Moratuwa, for spending your valuable time with us to share your vast knowledge on this field. So thank you, Mr. Samarasinghe, and we really appreciate your commitment, and we wish you all the best in your future endeavors. And Mr. H.A.Priyantha and Mr. Chandana Maddumabandara, both of you have added more value to this webinar by sharing your knowledge and experiences with us as electronic engineers of ASL and also as senior members of the ATEOA. So let me thank both of you also for being with us in this special occasion. And I need to mention Mr. Jananath Konara, who is the head of Electronics and Air Navigation Engineering Division of ASL, and all the sectional heads of our division for the continuous support extending towards ATEOA and its activities. There are two other special personnel who I need to thank. Mr. Thorsten Wehe, President of International Federation of Air Traffic Safety Electronics Association, and Mr. Senthilvel Balasubramaniam. He is the Asia Pacific Regional Director of Air Traffic International Federation of Air Traffic Safety Electronics Associations. These two gentlemen always work towards the well-being of global ATSEPs and also support us whenever we need. And A special thank goes to all the members of ATEO, including President, Secretary, and the Executive Committee for the effort you made to make this event a success. And finally, thank you all participants for spending your valuable time with us. I hope that you gain some interesting knowledge on air traffic safety, and I invite you all to share them with anyone interested on this field. And please forgive me if I miss any name to thank. And I take this opportunity to thank everyone who support us to successfully conduct this webinar. Wish you all a very good night and stay safe. Thank you. Over to you, Nwanji.
Thank you, Asiru. I have a special announcement to make. There will be an awareness session about story behind the safe air journey and the pivotal role of ATSEP in Big Focus program at 24 channel in TV Derana on 14th November at 11 AM. So you can join with channel 14 in POTV and Dialogue Connections. So I hope this will be interesting program for all of you. So this is our FB profile. So now you can see our FB profile. Yeah, so stay tuned with us for future events. Thank you very much for joining with us. Have a great evening.